In this video, we're going to talk about 5.2 Objective 1, where we identify and explain basic aspects of the 6895 99.7 rule, also known as the empirical rule. We'll also talk about standard scores and percentiles. I mentioned the empirical rule, or the 6895 99.7 rule, a little bit last time at the end of the 5.1 Objective 4 video, and you might want to go see the drawing that I made there in that video. But let's go ahead and get started here. In the 68, 95, 99.7 rule, what does the value 68 represent? The value 68 represents the fact that 68% of the data values in a normal distribution fall within one standard deviation of the mean. It doesn't ask us here, but I'm going to just keep going here and tell you that the 95 represents that 95% of the data values in a normal distribution fall within two standard deviations of the mean, and the 99.7 represents that 99.7% of the data values in a normal distribution fall within three standard deviations of the mean, meaning that only 0.3% of the data in a normal distribution fall outside of three standard deviations of the mean to the right and left. Right, and I made a chart of that last time with a drawing to show you if we were to split that up on the right and the left and how much would be in each little segment. We can add those segments up and get good approximations, good estimates, even for things that didn't exactly fall on the lines like that. So what is a standard score and how do you find the standard score for a particular data value? So the standard score that we're going to talk about here is going to be a z-score. There's another standard score we'll talk about later, but the z-score is going to be the number of standard deviations that a data value lies above or below the mean. So that's A. And we calculate the z-score by finding the distance of the data value is away from the mean. If it's less than the mean, it's to the left and it's going to be negative, and that's okay. And we divide by the standard deviation. So it's this distance here converted into a number of standard deviations away from the mean. Positive numbers are above. Positive z-values represent data that's above the mean and greater than the mean, and negative z-values represent those that are below or to the left of the mean. So we'll take a look at that next with this last question. What is a percentile, and describe how the accompanying table allows you to relate standard scores and percentiles. So this is very typical here of a Z table, and it's going to report percentiles usually, and it will usually go between negative 3.5 standard deviations and 3.5 standard deviations, because you see how close we're getting now to 0% below negative 3.5 and 100% being below 3.5. So we say that anything that is less than negative 3.5, we're just going to call that 0% to the left, and anything greater than 3.5, we're going to call that 100% to the left. Even if those numbers aren't on your table, we'll make that assumption. You see that as you go further to the right, you get more area to the left. That makes sense. And you see that at 0 right here at the mean, there's 50% to the left, which means there's going to be 50% to the right. That makes sense as well. But let's come back to our definition here. The percentile of a data value is the percentage of all data values in the data set that are less than or equal to it for the standard scores given in the table. The table gives the percentage of values in the distribution less than or equal to that value. So what we can do is we can take any normal distribution that has any mean and any standard deviation. We know that it's normal, and we can convert what we call a raw score, or the data up here, the data value in our formula. Sometimes we'll call that a raw score. and we can convert that to a z-value and then look it up in the z table here with its z-score. And we're going to usually, the table will usually round that z-score to 2 decimal places. Most of the z tables that I've seen, this one only rounds it to 1 decimal place. But most z tables will give you precision to 2 decimal places in your z-score, and then you'll be able to convert that to a percentile, which is to the nearest hundredth of a percent here. Another way that the table can report those values to you is just as a probability between 0 and 1. That's not a percent, but they'll give you 4 decimal places of precision, which is exactly the same thing as getting to the nearest hundredth of a percent. You just multiply by 100%, move that decimal point 2 places, add your percent sign, and you have a percentile instead of a probability. Just make sure that you know for sure that your table that you're looking at does show the area that's to the left, because there are different tables that are written different ways. Tables that we're going to use in this class for z values are going to be talking about area or relative frequency or probability that's represented that's to the left of the z-score. We'll be working more with those tables here very shortly. All right, that's it for this video. We'll come back next time and talk about 5.2 Objective 2. So we'll see you for the next video.